Until now, we have only used simple shapes to create our 3D scenes, such as cube, sphere, plane, and so on. But what will make our project stand out is the use of 3D models made with 3D modeling software, such as Blender, Maya, 3ds Max. In this course, we won't do 3D modeling as it's a whole topic on its own, and it's not a mandatory skill to create 3D experience with Three.js and React 3 Fiber, because you can find 3D models for free or paid ones online, and you can also collaborate with 3D designers. But still, at some point, I would recommend you to learn the basics of 3D modeling, as it can help you understand better how 3D models are made and how to integrate them better in your 3D projects. If you decide to follow this path, I recommend you to learn Blender, which is a free and open source 3D modeling software. It's a very powerful tool that includes all the features that you will need, and there are many tutorials available online to learn how to use it. The most famous one to get started is the donut tutorial by Blender Guru. You can find the link in the content of this lesson. 3D models are simple files that contain the information about the geometry, the texture, the animations of your meshes. There are many formats available for 3D models, such as OBJ that is containing mainly the geometry's information, FBX, which is a binary format containing all the information about your meshes, and it's the preferred format using Unity and Unreal Engine. Then you have GLTF, which is a JSON format, and it's the recommended format for web as it's a very compressed one. And GLB is the binary version of GLTF, so it's lighter. That's why most of the time we will want to use GLTF or GLB file formats. But because FBX files are used by Unity and Unreal Engine, a lot of 3D models available on stores or for free are made in FBX. Of course, it's very easy to convert them from FBX to GLTF GLB using Blender. Let's have a look at some websites where we can find the models, some free and some not. We have Polypizza, which is a collection of free low-poly 3D models. Most of them are royalty-free, which means you can use them without credit. But you need to be careful about it. When you do download GLB, they will tell you what are the attribution you need to declare. For example, CC BY means that you can use it in any kind of project, but you need to credit the author, and they have the link you can copy to put it into your project. Another great collection of free low-poly models is Quaternius. He provides a lot of packs that you can use in different types of project, for example, the sushi restaurant kit. And you can see here that the license is CC0, which means you don't have to credit, you can just use it directly. So don't hesitate to support the creator by joining its Patreon. Then we have Poimandres Market, which is made by the collective in charge of React 3 Fiber. It's also mainly low-poly ones. Let's open one. And one useful thing is that you have a React 3 Fiber tab, so you can copy the JSX scene graph and use it directly in your project easily. Then you have the marketplace Sketchfab, which is a reference for 3D models. There are all kinds of 3D models, but from here you will be able to find more realistic ones. There are many categories available and different filters based on the price, or also based on the license if you are looking only for CC0 ones. You can also find 3D models on Unity Asset Store or Unreal Engine Store. Some might require some extra words. For example, if you go into package contents, you will see all the available files. If you go into meshes, buildings, you can see it's a lot of FBX file. You might want to convert them into GLTF or GLB files. Now let's learn how to load and how to use 3D models inside our project. Inside the starter pack, I prepared some models from the Ultimate Monsters from Quaternius pack. The way I organize my project is inside public, I create a models folder with the different 3D models. Let's load one of them inside our experience. Go to Source, Components and Experience. We have a mesh, we can remove it and start coding our import. To load any resource into our project, we need to use a loader. To do so, there is the Use Loader hook by React 3 Fiber. The first parameter is the loader we want to use. Us, it will be GLTF loader. It's imported from 3 examples, GSM loader, GLTF loader. Then it's the path of the model. So it's models/fish.gltf. Why is it models while it's inside public? It's because the root folder when we deploy our project is the public one. So it's inside public, the first one is models. In this case, useLoader is returning us our model. To display it, we need to use a primitive, define its object. It will be model.scene. Now we can see our 3D model loaded into our project. But use loader is not the simplest way to load model with React Refiber. We can use instead use GLTF from dry library to load our model. So we just need to pass the path models/fish.gltf. It also returns the model, but we can destructurate it and directly get the scene. That way we don't need it anymore, neither the import and the use loader, and use here directly the scene. When we reload, we have exactly the same thing, but it's only one line of code. Our project also contains a dino.fbx model. Let's try to load it. There is, as use.gltf exists, we have use.fbx. And we will be doing models/dino.fbx. Let's name the return of it dino. Now we will need a primitive to display it, and the object will be dino. But we have two problems. It looks very big and there is no light, so it appears completely black. Let's adjust its scale, setting it to 0.01, and its exposition to -3. Now we have them side by side and they do almost the same size. We can add an ambient light to see the real color of our dino. Let's put the intensity to 1. Now we can see our two cute monsters. But there is even a simpler way to load a GLTF model, but it depends what kind of control you need over it, which is to use the GLTF component from dry. It works like an image, so you need the source path, models, fish.gltf. It's still displaying our model. It's very handy when you don't need any control over your model. But when we need to have control over our model, its animation and also the part of the meshes, we need to create components from it. The tool to automate this process is named GLTF JSX. It's a command line tool that we will execute on our model and it will generate a React component from it. Let's see how to use it. We can run npx to not have to install it on our device manually. GLTF JSX, the path to the model, which is public, models, and fish.gltf. Then the output, we can use -o, we'll put it in source, components, and fish.jsx. And to set the root directory, we will say public. Let's look what it did. We open our files, component, and now we have a fish component. Say auto-generated by GLTF JSX and what the command was used. So we know the version of GLTF JSX used. It wrote all the code automatically for us. For example, the use GLTF part, the use animations that we will see just after, and it automatically detected inside the 3D model the different meshes available, so we can have control over each of them programmatically. And on the bottom of the file, it's also using use.gltf preload to preload the model when we start the application. We will talk more about it into the loading screen lesson. I usually change the name of the component, which is model by default, to the name of my file. So fish.jsx is fish. Let's try to use it. Go to experience. Here, replace the GLTF with the fish component. It's still working exactly the same, but now we have control over our component. There is also an online version of GLTF JSX where you can drag and drop your model instead of the command line tool. You can drag and drop your file or try with Suzanne, which is the monkey from Blender. And you can see what it does for you. You copy the code and you're ready. Let's remove the dino and see how to animate our fish here. You can see that GLTF JSX automatically detected that there are animations in the file, and it's using the use animations hook to help us create actions and perform animations on our model. Before explaining how it works, let's look at all the available actions we have. Console.log actions. Let's open the console and we can see we have an object here with all the different animations available on that 3D model. If we open one of them, the death animation, it's an animation action. Then you have all the parameters you can play with 3JS. But what is an animation? It's a sequence of keyframes. So if you go into the clip, you have a lot of tracks. Each track is associated to one bone. So for example, you can see the foot left, the body, it will impact either its position or its quaternion, so its rotation. And if we open one of them, we can see it just values over time, changing the position of anything or the rotation or scale. To understand in depth how animations work in Three.js, I recommend you to read the animation system part in the Three.js documentation. So before playing those animations, let's look at what we have because it was automatically generated. We have from UseGLTF the animations found in the 3D model. Then we need to use animations hook with the array of animations clip found in the animations. And the second parameter it takes is an object 3D, which is for us our main group, the root group. Use animations under the hood is creating a mixer that will allow us to play different actions. So we receive the actions, but we could also get the mixer if we want to go more in depth, but it's not something we will see together. You can find more info about it in the Three.js documentation, but we won't require it. And on those actions, we will be able to play them. Let's add a picker with Leva to be able to choose different animation. Let's create animation is equal to use controls from Leva. We'll name it animation. The value by default will be empty, so we don't have an animation. The different options we will use, which will create a drop-down for us using Leva. It's an array of string, object.keys of actions. The keys are the one we saw previously, death, duck, hit react, and so on. Okay, we can save it. Now on the top right, we have the animation. We can choose between different ones. Let's set the default one to idle. And with a use effect based on the animation. So in the array of dependency, we'll put the animation. So every time animation change, use effect will be triggered. We will do actions of animation and play. Now if we reload, we can see it's in idle stance. If we change it to jump, we see it's doing something very weird. It's because we need to stop the previous animation or they are all playing simultaneously. This is where the cleanup function from useEffect will help us. We can do return actions of animation.stop. So it will stop the previous animation and play the new one. Now we are in idle. We can jump and it's not buggy anymore. We can try to walk and it changed to walk without playing the previous one. But we have two issues. When we change to a different animation, it's very direct. It's not smooth. And also, when we play back another animations, it's not starting from the beginning of the animation, but from where it stopped. To make it start from the beginning of the animation, before playing, we can put reset. So we are sure it plays from the first keyframe. Then to add smooth transition between different animations, we can add fade in when we play it. We set the duration in seconds and fade out. And same applies, the duration in seconds. When we do fade out, we don't have to stop. It will stop at the end of the fade out. Let's try it again, change from idle to punch. And you can see it's seamless. We don't see a jump. So it's quite nice. Our fish is now perfectly animated. If you need to fine-tune your animations, you can have a look at the animation mixer documentation from Three.js. For example, impacting the time will speed up or slow down your animation. You can also have a look at the animation action documentation, which have a lot of properties. For example, to stop looping, so it will only happen once. It depends what you need on your project. You can say once, repeat, or ping pong, so it will play in both sides. And you can also impact the time for one single action, making it slower or faster. Our 3D models contain only one character, but you might have cases where you want to have 10 different characters and choose them programmatically. It really depends on your project. If you need to display your 10 models, it will be easier to have them in one single file. But if you only use once at a time, having one model per file might also work. But if those models share the same animation, for example, the idle, jump, run, walk are the same animations, you don't want to pack the animations in each model file. You can have an animation file containing all the animation that you can use on the different models. I also recommend you to read the loading models section in React Refiber documentation. It's always good to cross-reference the information you get from tutorials so you understand it better.